So in the previous video, we set the foundations for creating procedural lightning effects. We covered so many techniques there. Now it is time to level it up by creating this directional lightning effect. By the way, before we start, if you haven't checked out my ultimate lightning pack, this is the best time to do so. I just released a new update. So let's move on to creating this lightning effect from our ultimate lightning pack. Let's start by adding a plane to be our geometry node object. I rename it to Directional Lightning. Then add an empty to be our directional target. This empty will decide the direction of the lightning and also its length. I place both of these objects like this. Go to Geometry Node Workspace. Create a new GeoNode setup. Rename it and pin the window. Just like in the previous tutorial, I delete our group input node. Now it is pretty much the same process as before. We need a curve line node to act as our main lightning branch. Drag our target object into the setup. Set it to relative and plug it to the end socket. This will stick the endpoint to the target object. Let's create a reference to our self object by duplicating the object info node and keeping the object slot empty. Drag its location to the start socket. This is exactly what we did last time. You can keep things like this and move forward, but I like to switch to the direction method. Immediately, we lost our end socket and its connection. That's fine. Now we have this direction vector input. Here we have to tell it which direction we want our line to go. But right now we only have access to the location vector of our lightning branch object and our target object. So how do we find the direction from one vector point to another? Well, it is very simple. All we have to do is subtract the two vectors. Use a vector math subtract node and plug the two locations. Then plug the subtracted result to direction input. Now in the viewport you can see our curve is actually facing away from the target object. We certainly got the direction right, but it is the negative direction. Let me increase the length so you can see it clearly. So in order to make our line directed towards the target, just flip these two vectors. Now you can see it is pointing towards our target object, which is exactly what we want. So long story short, if you want to find the direction vector between two vectors, then just subtract them. That will do the job. You can change the length from here. But I actually want my endpoint to stick to this target object. So if I find the distance between the lightning object and our target object, we can assign that as our length. In order to find that, I hit Ctrl+Shift+D to duplicate the subtract vector node without losing its connections. Then change the math type to distance. This will calculate the distance between two input vectors and output it as a float value. Plug that into our length. It is working. Yes, I know you may be wondering, we could have used the point method to create this exact same setup with less nodes, just like the previous tutorial. Actually, you are right. You can use the same method, but here I wanted to show you guys this option. And also we will use our direction calculation later in the node setup. So I keep things like this. Now we need to create distortions, but we have only 2 points. So let's add more points to the curve by using curve resample curve node. Last time I used that count method, but based on you guys' feedback and also my own usage, I felt like this wanted a more adaptive method. So change this to length. Let's add a viewer node to see what it does. I want you to look at this number right here. Amount of points we have on our curve right now, it is 170. Before the resample node, it says 2. So it took our curve and converted it to have 117 points based on our length value, which means it created a point at every 0.1 meter along the curve. You can see it clearly when I change the location of the target object. It takes the total length to account and create a point at every 0.1 meter. Smaller the curve, less points, and longer the curve, more points. In our previous method, we had to add the points number manually. But this way, I think it will be more user-friendly, and also you will spend less time adjusting the resolution. Let's organize these. Remember why? Now, let's move on to create distortions. I will repeat exactly what I did in the previous tutorial. Use a set position node, add a noise texture and set it to 4D. Use a map range to remap the 0 to 1 value range into -1 to 1 and plug them to offset. I talked about all the reasons behind each of these steps in the previous video. Right? Lower the scale and play with other values to get something like this. Then add a vector map scale node to control the strength of our distortion. Let's place it like this. To make the start point of our curve stick to its point without getting distorted, I use a spline parameter node and run it through a multiply node. Plug the output to scale. Now, this second value will control the distortion strength. This spline parameter, which gives us 0 to 1 value range, will fully distort the curve at the end and 0 distortion at the start. Here I am fine with the endpoint getting distorted. But I need a bit more distortion in the middle. So let's use a float curve and put it in the middle and change it like this. Last time we changed it like this to have both of our start and end point to stick to their places. But here, since I only want the start point to have no distortion, I change it like this. This is exactly why I created the previous tutorial, to cover all the basics we need. I can go through those steps quickly today and take my time to explain anything new. Let's adjust some values a bit. Also, let's add a scene time node to animate the offset. Use a multiply math node to control its speed or frequency. Just for now, I set it to 0. We add our big distortion. Let's add tiny bit distortion to get that jittering look. For that second layer of distortion, I simply duplicate this whole setup. Since distortion is nothing big, you can remove this part of the setup or simply adjust the curve to something like this. This way, we have full distortion in majority of the curve. Increase the noise scale and reduce the strength to get something like this. I like this. Let's move on to create our branches. The way we create branches is we are going to populate curve lines along the control points in our main branch. For that, drag from here and use instance on points node. You can find it here in the menu as well. Right now we have 117 points in this curve. That means we have 117 instances, which means in our case 117 secondary branches. So Let's create those branches by plugging a curve line node to the instance socket. Now, when I plug this into group output node, you can see we have plenty of curve lines populated from our main curve. In order to see both secondary branches and our main curve, we need to join these two together. For that, we can use geometry join geometry node. Okay, at the moment we have too many branches. So in order to reduce that amount, we can control which points we use to instance the branches through this selection socket. Drag from here and search for random value node. Since we drag from a Boolean socket, it gives us random value node with this Boolean data type, which is what we want, because now using this probability slider, we can control the amount of branches we see in the main branch. 1 will give us all the branches and 0 will give us no branches. Around 0.25 is a good number, I think. Also, I don't want branches in every single area in the main branch. I want users to have control over where the branches needs to be, whether he wants to start them from halfway through the main branch or at the very end of the branch. Spline parameter node we used before gives us a 0 to 1 gradient from the start to end of the curve. We can use that to mask out an area where we want our branches to be. So, add a spline parameter. Let's say I want to see branches in an area where spline parameter value is greater than 0.2 or 0.3, something like that. We can create that logic or that mask using greater than node. Here you can see we have two greater than options. One is a compare node and the other is a math node. Let's see the math node first. You can see from this gray color, it outputs a float value. And compare math node outputs Boolean values. Actually, with greater than math type, both of them output either 1 or 0, or true or false. If your logic is true, it outputs 1 and 0 if it is false. Both of them will work, but here I use compare greater than node. Our selection socket is also a Boolean output, so it will work fine. Now using this B value, we can control the area we want our instances. When the logic is true, we will get the branches. When I set this to 0, you can see we have almost every single branch, except for the first one, because at the first point our spline parameter value is 0, and 0 is not greater than 0. But if I set this to greater than or equal, then we get all the branches including the first one, because now we are counting the 0 as well. I change it back to greater than. You can keep it if you want to. Let's set the mask distance to around 0.2. But now you can see we can only have either this or this, not both. What I want is, I want to mask out the area and then pick random points from that. In other words, I want branches only in points where both of these logics are true. In Boolean math, we can use AND math type for that. So let's drag from here and search for AND Boolean math node. Plug these two and plug the output to the selection socket. Now you can see it is working nicely. You can also see sometimes we get these branches very close to each other, and that could look a little ugly, especially when we add distortion to the branches. So I also want to create a logic which removes branches that are next to each other. I start creating that logic by adding an input index node. This gives us the index number of each point of the curve. You can see that here. Now I take that index and divide it by 2. This gives us the result that it should. But what I want is the remaining value. When we divide the index by 2, I want to see the remaining value. For that, I can use this modulo method type instead of divide. Now you can see it gives us this 0101 pattern as the result. If you want a 0101 pattern anywhere like this, you can simply get that by using this method. Any positive number divided by 2 will give us either 1 or 0 as the remaining. If the index number is an odd number, it will give us 1, and if it is an even number, then 0. And 1 and 0 mean true and false. So let's add this to our selection. Duplicate the AND math node and plug this to output. Now you can see we get branches only when all 3 of these logics are true. Here you can clearly see that we are removing the branches in the middle. If you want to see a good use case of this modulo math type, then check my digital timer tutorial. And I want to expand our selection even more. I don't like to see branches at the endpoint of the main branch. There can be moments where all 3 of these logics are true at the endpoint. I don't want that. So let's eliminate that point from our selection. For that, I can use curve endpoint selection curve. Although we didn't use this in the last video, we talked about this a bit there. What this does is it gives us a selection of points from each end of the curve. Since I want the last point of the curve, I set the start to 0 and end to 1. Now I duplicate the math node and plug this. Everything is gone because now it tries to find that rare moment where all of these logics are true. But what we want is to remove the endpoint from the selection we got from the previous logics. So let's switch these two inputs and change the math type to subtract. And now this will subtract or remove the endpoint from our selection, just like we wanted. You can see that clearly when I mute this and set the probability to 1. So that's how we created our selection for the branches. If you're okay with having the endpoint also turning to a branch, then you can ignore that last step. You can change this seed value to change the distribution of the branches. Now all of our branches are pointing directly up. I want them to angle towards the same target object. Few ways we can do that, but the most effective way is to use the direction calculation we made earlier. So I switch this to direction method and find our direction from all the way from here. Drag from it and add a reroute node. Let's add another one. We can plug this to direction here, and you can see all of our branches angled towards the target. I mean, they are parallel to main branch direction. This will work, but I have a better way to do this. So set this back to point method. First, let's randomize this branch rotation before angling them to target. I drag from here and get a random value node. This time a vector values. Minimum and maximum rotation I want is minus 180 degrees and positive 180 degrees to get that full 360 degree rotation. But unfortunately we can't type degree values here, but we can put the radian equivalent of those values. So to get a negative 180 degrees, here I select all of these 3 axes and type negative pi. For the maximum I type pi. This will give us the radian equivalent of those degrees values. If you haven't ever done this, Yes, you can type different things here to get some values that you probably don't know by memory. If you want 360 degrees, then you can type 2 pi or tau. If you want 90 degrees, then type pi divided by 2, like that. I set this back to pi. Now you can see our branches are freely rotated. To make them angle a bit towards the target, I drag from here and search for a line Euler to vector node. Make sure you plug it to rotation. Now I select the Z axis from here. Plug the output to instance rotation. Now you can see it's pointing up again, but if we change this factor, you will see it makes between our random value and this second vector input, which is what makes these pointing upwards. Now you might have already guessed, yes, I am going to drag our direction to that second vector. Then I can change this factor to find a better value. I tried few different ways to control the rotation of the branches. This is the one that I find has a better look overall. If you want to know how to point each of instances directly at one target rather than what we did here, then check how I did the hologram beams in my hologram tutorial. All our branches are the same size. Let's change that too. Add a random value node to scale. Now you can see all of our branches are different sizes, but since we are scaling them randomly in 3 axes differently, these branches can stretch more on a certain axis than the other, which could give us weird results when we add distortions. What we should do is add random scaling but uniform in all axes. So I change this from vector to float. This will add that random value to all 3 axes. Pick a number between 0 and 1. This way we can scale our branches without stretching them. We can use this min and max to change the length. Actually, since the curved line we use as an instance source is 1 meter long, then this 1 here in the max is also equal to 1 meter. 2.5 here means 2.5 meters, like that, because these scaling values always multiply to give the final scale. And another thing is I want the scale of the branches to be higher at the start of the main branch, and towards the end I want the branches length to be small. So to access the main branch I use the spline parameter again. Here it will access the spline parameter factor from the main branch. Add a map range node, plug it to scale. We don't need this random value now. If you want, you can keep it and then multiply it with the map range node. Because of our spline parameter, branches that are closer to the start will have a scale close to 0, which is the opposite of what we want. We can flip that by flipping the 2 min and 2 max values. You can adjust the minimum and maximum scale of the branches by changing these 2 values. This way, we have a gradual fall off of branches length along the main branch. If you want to randomize that even more, then like I said before, you can multiply this with the previous random value node. Oh, we forgot to organize this. Let's call this main branch distortion 1 and 2. You can add reroute nodes by holding shift, right click dragging over any noodle. Now let's distort our secondary branches as well. Before that, add a resample node and set it to length. And now I copy this whole distortion setup we made earlier and put it here. Well, it's not doing anything. It is because we are using the spline parameter in our distortion setup. Let's view the output. Here in the instances, you can see it says 0. But the biggest problem is it displays its data on this instances section, not the curve section. That is because these branches are not curves, they are instances. We use a spline parameter with curves. It does not work with instances, which means this resample node is also not working because it takes curves as its input, but we plug instances. In geometry nodes, at least to my knowledge, with instances we can only do a limited amount of things. Just look at the size of this instance menu. We can only do things like rotation and scale. So we need to convert all of these instances to curves if we need to make any of the curve nodes work. For that, we can use this instances realize instances node. Now, if you look at the spreadsheet, you can see our instances are gone and now we have more points and 15 splines, which means those 14 branches we had as instances have converted to curves, and now it says 15 with the main branch. Also in the viewport you can see our distortion is working. Now adjust the distortion settings to get something like this. To get more resolution for the second layer of distortion, I add a subdivide curve node. This will subdivide the curve. 1 or 2 levels of cuts is fine. Then add the second layer of distortion. Here is a quick before and after. Now let's change these to mesh. Use curve to mesh node and plug curve circle as profile curve. Adjust the radius. Here I reduce the resolution to 6. 32 is unnecessary, especially when we add the emission shader. We won't be able to see the difference between resolution of 6 or anything higher. So, just like we did in the previous tutorial, let's adjust the curve radius by adding a set curve radius node. Add a spline parameter and change the values using a float curve. It is working, bigger radius at the start and 0 at the end. But it is only in the main branch though. We have an issue in the secondary branches. You can see that clearly at the end of the lightning. Their start radius is bigger than the place they have connected in the main branch. It is like they suddenly found a new energy. In the secondary branches, they have the radius fall-off we created, but I want the start radius of the secondary branches to have a similar radius to the point they have attached to in the main branch. Right now this is happening because we are adding the set curve radius node to both curves at once. And when we use the spline parameter, it looks at each individual curve in the lightning and then changes their radius based on their individual parameter data. There are no connection between the main branch's radius and the secondary branch's radius. So the best possible way I found to make those connections is by adjusting the radius separately for the main branch and for the secondary branches. So remove this connection from here and drag these three nodes all the way to here. Create a reroute node by shift-click drag over these two noodles. By the way, you can maximize your view by hitting Ctrl space. Place them here. You can see our main branch has the radius follow we created. Now we have to use this radius to change the radius of the secondary branches. Let's do it over here. Now, just like before, add a set curve radius node and spline parameter along with float curve to change the radius. Okay, we are back to where we were a few seconds ago. So what I'm trying to do is, because of our spline parameter and float curve, our main branch's radius goes from 1 to 0. Let's just say right here that value is 0.1. And this branch is also going from 1 to 0. But I want it to go from 0.1 to 0. That way we can create the effect we want. For another example, let's just say here the main branch radius is 0.7. Then I want this secondary branch to have a radius that goes from 0.7 to 0 instead of just 1 to 0. So how are we going to do that? Actually, the technique is simple. You might have guessed it already. If we multiply the secondary branch's radius with the radius of the points they are attached to in the main branch, then we can get what we want. Add a multiply node and let's see what will happen if we plug another spline parameter node to get the main branch radius. Not working, right? Actually, there's no difference between this spline parameter and this one, because spline parameters do not contain data. They give us the access to get data from a certain geometry we plug that into. So in this case, both of these access the data from the branches. So how do we access the data from the main branch? If you thought to plug this, well, still it won't work, because it is the exact same thing. Just because this is here, it doesn't mean this will give us the main branch radius. So we need a way to capture this radius we made at this moment in the branch. Remember we used a store attribute node to store some data in the previous tutorial? Just like that, here we can use the capture attribute node to capture this radius follow we created. Drag this to this value socket. Now I can drag from this output attribute socket and plug it to our socket in the multiply node. What happened here is, when it is time to multiply, it comes here and sees that we are multiplying not just from the spline parameter, we are multiplying from the spline parameter of this curve. Since our branches come from the points of the main branch, it can easily add the spline parameter value from that point to the branches without messing things up. Use a reroute node to organize these. Now let's create the striking effect. We can use trim curve node like before, but you can see just like before with the radius, we have an issue. And it is for the same reason. Trim curve node treat each spline separately. It has no clue of which branches at the end of the main branch to start trimming them early. So does this mean we have to do the similar thing like we did with the radius? Actually, no. Since we created our own value range for the lightning here with the radius, we can use that radius to do anything to the lightning. That radius knows where exactly each point in the lightning is. Now, look at what will happen when I set this radius to 0. Our branches is gone. That means instead of using the trim curve node, we can use the radius and set it to 0 to give the illusion of trimming the curve. Let's add a set curve radius node. Immediately, you can see all of our hard work just vanished. The radius follow we created is gone. That is because this node literally sets the radius. It is going to overwrite anything it had before. But lucky for us, we set our radius for the lightning before. In other words, until this node overwrites it, it exists. And in the geometry node, we can access the current radius of any curve by going to input radius node. Now, if I view this with our joint geometry, you can see here in the spreadsheet, we have our radius values we set for the curve going from 1 to 0. So let's plug this in here. We got our radius back. We just override the current radius with itself. Now, if I add a map range node here, I can change the mapping of that radius value. See what happens when I change the from mean value. Our lightning is getting trimmed. By default, map range takes values from 0 to 1 like we have for radius and remap them to 0 to 1. But if I set the minimum input to something like 0.5, that means everything below 0.5 will output as 0. 0.5 to 1 will remap to 0 to 1. And for us, this will look like our curve getting trimmed. At the moment, this value can go beyond 0 to 1 range, but we don't need to worry about that. We will create a slider for this that only goes from 0 to 1. So this is how we created our striking without using the trim curve. Trim curve is a handy node to use like we did in the previous video, but unfortunately not here. Now, just like before, I will create everything else we need for our lightning effect. Since this is very similar steps to what I did in the last video, I'll quickly go through this. Create a material parameters like we did before. This time, the only difference is I will use the radius as my x input and I will use y-axis as the hue value for my second color. That is something I forgot in the last video. I plug the y-axis value to hue input in the second color of our lightning. Hue value of 0.5 means exactly the same value as our input color. Anything below or higher will give us different colors. I usually keep that value just about 0.5. You can smooth out the curves. Make sure to organize your nodes. Here's a quick glance at what we did so far. Check whether you missed anything. Now, just like before, extract the values you need. Name them appropriately and set the default values and min and max values as well. Here I use the prefix 1 and 2 to imply the distortion level. And if you want a slider input, then use any node with a slider and plug it to create a new slider input. Here, I did that to our striking value. Also, since our striking is happening in reverse, to invert that, I use this 1 minus method, which means I subtract that value from 1. This way, we can create the striking effect when the slider goes from 0 to 1. Without that math node, it will happen from 1 to 0, which does not really make sense, especially when you ship your nodes to someone else. Reorder the inputs. Now, when you look at this huge number of inputs, it definitely gives you headaches, right? So, let's create some dividers and separate them into sections. There's no any specific way to section anything in Blender, but this is the method that I use. Here, after this resolution input, we have our inputs for controlling the distortion. So I will select this resolution input and create a new one just below it. Change its type to string. Remove the name. Now you can see it did this, which is a good way to separate inputs. I create a few more of these to separate inputs into sections. After that, you can type the name of that section as a string input. But since this is an input, if you use this modifier somewhere else, this will be blank by default. So copy the name you entered and paste it here in the default value section. Now, when you add this modifier to another object, this will be there by default. Ctrl H to hide the unused sockets. Organize your nodes and you will have your effect. By the way, if you want to animate the branch distribution randomly, then use a scene time node with multiply add node for that. Using these techniques, you can easily upgrade this lightning to 3 levels of branches. Here you can see because of the adaptive resolution, it looks way better when you change the length. So this is our directional lightning effect. If you like to grab the free ultimate lightning pack, go ahead and do so. If you're so much interested in creating these procedural effects, then you can grab the extra pack with a lot more effects and demos. Or you can check out the ultimate suit up pack. So I hope you learned something cool, something useful. I mean, that's what we love to do. We not only create stuff, we let you create with us. Hit that like button, comment your thoughts below, and don't forget to subscribe to HelloFX Learn so you won't miss out when the next video drops. Huge thanks to our awesome patrons, and until we meet next time, you can check these videos out. You're gonna love them.